Hello everyone, my name is Jesus Palomer. In this video we will see the practical work number 4 about the automatic extraction of coastlines from satellite images. In this practical work, we will see how to use SAET to estimate the impact caused by the coastal storm Gloria in an area of the Spanish Mediterranean coast. Let's start with the exercise. Hello everyone. Once we have SAET installed, we are going to use this software to determine what the effects of Storm Gloria were in a certain area of the Spanish coast. First of all, we will see what Sentinel-2 tiles we need for this study area. Obviously, we will use the dates closest to the peak of the storm, and with the lowest possible cloud coverage. Then we will download these images and we will process them. The software we are going to use is SAET and QGIS. As additional information, we can highlight this link where there is information about Storm Gloria, which had its maximum peak around the 20th of January of 2020. The images we are going to process are Sentinel-2. The study area will be the Valencian coast. Additionally, it would be recommendable to review these two documents, the file examples of use (txt) and this web page where it comes from the description of SAET, as well as the needed parameters to use SAET. A good understanding of these parameters is necessary to use the software correctly. First of all, to plan the processing, we will open the QGIS project that is located in the aux data folder. Within the SAET installation folder, first of all we are going to zoom into the area of interest. In this case, it is this area of the Valencian coast. The first thing we are going to do is find out which tiles overlap with the area of interest. In this case, this green polygon layer is the layer that corresponds to the tiles of every Sentinel-2 scene. Let's use the information tool to find out which tile corresponds to this area. It tells us that the code the tail we are interested in is this one we have here, 30sig. On the other hand, we can see that we have a layer of polygons in red. That layer of polygons indicates where the beaches are. Beaches are the most interesting areas to study, since they would be the most affected areas. Areas where there are cliffs or rigid areas would be less interesting, since they would not have relevant changes. This polygon layer can be modified according to the user's needs, being able to add more polygons, removing polygons or modifying those we want. This way, we can use of SAET in any area of the world. Therefore, once we know these parameters, we will use SAET to search for those Sentinel-2 images corresponding to the analysis area. In this case, we are going to follow these parameters. We will search the images around the date where the storm had its greatest strength, that is, its peak, which occurred around the 20th of January of 2020. Therefore, let's look for the images included within of this date range, from January 1 to February 10th. Besides, these images will have a maximum cloud coverage of 30%. The images we are going to look for are Sentinel-2 level 1, and the tail, previously mentioned, is 30sig. Therefore, this is the sentence we are going to write in the command prompt to use SAET in searching mode. The script that we are going to run is the one called searching run, with these parameters, which are the ones we have commented right now. First of all, the first thing we are going to do is run this bat file. In order to activate the virtual environment to work with SAET, here we have it. Next, we can open the usage examples file and navigate to the example number 3. We can copy the sentence and paste it into the command window. In this command, we are running Python with the searching run script and the following parameters: footprint, indicating that we are not going to do a search by coordinates but by tail, the search start date, the search end date, the central date, which coincides with the peak of the storm, and the maximum level of cloud cover. The type of product we are going to use is Sentinel-2, so these two next parameters are for Landsat images. And these last two are for Sentinel-2, which are indicating the type of product, Sentinel-2 level 1 and the tail code. If we run this command by pressing Enter, we'll see what happens. A new page in the browser is opened, showing the images that are within that search range. We see several image quick looks showing the amount of clouds and its distribution. Likewise, we can see some basic data about each image, indicating their name, level of cloud cover, the days since that image was taken with respect to the central date of storm peak, and finally, if that image is online or not online. We see that it will be very interesting to verify that although it has few clouds, those clouds are not covering the area of analysis. This would mean that this image would be valid. In case that, although there are few clouds, those clouds cover part of the coast, that image would not be valid. In the same way, we see that in the command window, we have obtained a result showing images that have been found within the date range, ordered from highest to lowest date with respect to the central date of the peak of the storm, so that we can see how many days before or after the central date the images were taken, and also their percentage of clouds. Then, we will process those images that are closer, before or after the central date of the peak of the storm, and that they have very few clouds. Let's return now to the usage examples file. Let's go to the example number 5. This example is the continuation of the example 3. We already know what images have been found, and now we are going to download the images with closest dates to the peak of the storm and with less percentage of clouds. As we can see, each image has a code at the beginning. It is the image number. In this case, we will be interested in downloading images 3 and 4. We can go back to this same file and copy the sentence that we have on the screen. Paste it on the command prompt line. In this case, we are going to run the script downloading run, with the parameter SB indicating that the product for downloading is Sentinel-2. After running, a list of images we can download appear in the screen. Besides, the script is waiting for us to indicate which of them we want to download. We have several options, ***, to download all the images, a list to download only a few, or a range of images to download. All those that fall within that range. In this case, we are going to download images 3 and 4. Images are being downloaded. Once the process have finished, we can see on the screen how long it took to complete this process. If we go to the SAET installation directory, we can see that a folder named Output Data has been created. Inside that folder we have the Data folder and the Sentinel-2 STWO folder. Here we have the 2 downloaded images with all its bands. These are the bands that we are going to use to process each of the images. Now we go back to the QGIS project and let's see how we can perform the shoreline extraction process only for a beach that we are interested in. The whole scene covers a big number of beaches, but to facilitate the analysis and to make the analysis go faster, we are going to indicate that this analysis affects only one beach. In this case, we are going to choose this one here. This beach has 2076. That code is in the beach code field. This is a very important field since, if we want to add more beach polygons, we will have to add a new code. Different from any of the ones there was already in this database, that is, no beach must have a repeated code. This is very important. Before processing the images, it is very important that we know well the parameters of use and processing with SAET. We can go to this website to the Running SAET section. Parameters are explained here. Each SAET phases, searching, downloading or processing, have their own parameters. These parameters and their use are described in these tables. Most important, once we have searched and downloaded the images, is the processing phase. In this phase, we have these parameters, which are very important parameters. The first one is the method that we are going to use to detect water from non-water, using water indices. In this case, SAET supports 3 water indices. By default, SAET uses orange, which is one of the best works in most situations. Is this index orange? Next we have the segmentation method. In this case, we are going to use the standard, which is the value 0. This value is used as a threshold to obtain a binary map with water and non-water pixels, based on the water index aforementioned. Next parameter is in charge of obtain the shoreline at pixel level, which in this case is achieved by applying a series of morphological operators. SAET provide 2 of them, erosion and dilation. The default parameters always appear in the last column. The cloud mask processing level is a method that allows you to remove all those pixels that have been classified as clouds. These pixels would not be taken into account in the analysis. This parameter, which indicates the analysis kernel, is a SAET internal parameter for the subpixel algorithm, allowing the window's analysis size on the pixel line obtained in image segmentation, being smaller or bigger. The value by default it is 3. Finally, this is a parameter that allows us filtering by beach code, so that our analysis focuses only on a sector of the coast and does not throughout the scene. This is also useful in case we need test SAET first in a small area and then, once the extraction process has been found to be successful, we can analyze the rest of the scene. Well, to save some time recording the video, we have processed the images with these parameters. This is the script to run with Python, processing run. In this case, we have analyzed the beach with code 2076. Besides, we have changed the default water index using, in this case, the MNY index. When you run this script, we must to enter which are the images that we want to process, among which we already have downloaded. This would allow us to reprocess some images changing some parameters, because the coastline knot has been well detected, or because we want process other types of images, always from those previously downloaded. Once we indicate the images to be processed, in this case the images 0 and 1 from this list, the process will begin. All the steps of this process in SAET are described in this screen. In this line we see the progress, what indicates how the coastline points are extracted. Finally, when you finish with the first scene, this is the time taken for the process. We'll continue with the next scene. In this case, we have 2 scenes. Finally, the process will end. In the folder named SDS, the extracted coastlines will be stored in 2 formats, JSON and shapefile format. Let's see in the QGIS project those 2 extracted coastlines. In green color we have the pre-storm shoreline, and in red color the post-storm shoreline. In this case, we see that the January 16th line is the green line, and the January 26th line is the red line. Between these 2 dates, the peak of the storm occurred. We can clearly see how there has been a process of erosion of the line of coast along its entire length. This tells us that the effect of the storm was considerable. We can even measure to have an estimate value of that erosion. We are talking about between 30 and 40 meters of erosion between these 2 dates. With this, we finish the analysis of the effect of this storm in this sector of the coast.